Hello guys, welcome to another episode of CUDA Education. Today is a quick one. Today we are going to go down the ray tracing shadows rabbit hole. I've kind of, at this point, I'm kind of done with reflections for now, and we are going to start to investigate the shadows algorithm. Um, so we basically we're at ray tracing shadows. Before the previous videos we were doing ray tracing reflections. Again guys, if you want to join in on the fun, get tutorial number 1, which installs the Vulkan API on a Windows based machine with a Vulkan capable GPU. Tutorial number 15 installs all of these examples that you see here in the sidebar. If you want to be able to run the ray tracing examples, you need to make sure that your GPU is ray tracing capable. For NVIDIA, that means RTX, an RTX card and above. I don't know about the other vendors. All right, so we're in the ray tracing shadows algorithm, and I'll just run it just to see what we're dealing with. So basically, as you could maybe suspect, we're dealing with shadows now. And how do you process shadows? So as you can see, we have a light source that is bouncing around our object of interest, as you can see. And you notice that as the light source moves, so does the shadow of the object move, right? Now this makes sense. We can't exactly see the light source itself, but as you can see, there's a light source and it moves around, and we have our object, and then the object casts a shadow, right? It's a very simple sort of situation, right? It's not rocket science, and actually we're doing this in the ray tracing context, right? So this is not artificially created shadows. We're not doing any kind of computer graphics tricks in order to get these shadows. These shadows are naturally being created based on the process of ray tracing. Okay, so this is just my initial video. Still have to investigate a lot with this algorithm, but there are a couple of things that I could sort of, talk about from the jump. The first is that the shadows look pretty good and they look pretty accurate, and it looks like it's real. It doesn't look like it's artificial or anything like that, or man-made or what have you. So that's pretty cool. Um, the second thing is that we generally, for the most part, you know, we're following our ray tracing sort of usual suspects, right? It's a ray tracing thing. So we have rays that are generated, a ray gen. We have a ray gen shader. It traverses a scene. In this case, we are traversing this. The scene is this object here, and we're traversing the scene. We hit stuff, so we hit the object, and then let's say it bounces back and hits the camera, so we could actually see the object. And then we have our mist shader, right? So the usual suspects. We have our background thing. So if rays traverse the scene and they don't hit anything, we get this blue background color. The shadow part of the equation comes in when we start talking about how to create the shadow, right? So for all of our other algorithms, we didn't really have a shadow. We would have a platform maybe, and we would have objects in the platform. The platform, the light source will hit the objects on the in the scene, but it would never cast a shadow. In this example, of course, we're casting a shadow. Why is that? So going along with our rays traversing the scene. So we have rays traversing the scene. Some hit the object. It bounces back to the camera, and then we see our object. We have mist shaders, which basically traverse the scene and doesn't hit anything. And we have our sky model, or our background color. In this case, it's blue. So we have our hit. Right. So we have our ray gen. So the ray gen is, of course, we're generating rays that are being traversed across the scene. So we have our ray gen, we have our hit, and we have our miss. Okay, well, for the shadows we have an extra shader. Okay, so we have our regular mist shader, but then we have an extra mist shader. And what is basically happening is that rays are being generated um, when there is a hit. um, an extra ray is being generated. Okay, now I will get into this deeper in other videos, but basically another ray is being generated, and what that ray does, and I guess it's being generated for all pixels and rays, in the scene. And what that ray does is that it so let's say I know the light source is bouncing across the scene or whatever, but let's say um over here we have this thing, right? So let's say we paused it and we had this shadow right here, right? Let's say we had our shadow right here. Actually, I think I could just 1 second, just to make it a little bit more right. um so actually I'll just pause it like this, since I could do that. Okay. Okay, so we have rays traversing the scene, and then we have our shadow right here. Okay, so what happens is that for all the pixels, for all the rays in the sorry. So so we have our all the rays that are in the scene. We have for every ray that's in the scene, what happens is that an extra ray is being generated. So we have our hit shaders and all that stuff, but there's an extra ray being generated that basically goes from its point back to the light source, right? So we have a ray going from its point back to the light source. Now, if the ray hits something in between going from a point back to the light source, if there's an intersection, then we say, okay, that ray is a shadow, or that pixel is a shadow, right? Because when you trace, remember the light source is coming in this way now, right? Something like that. So when you trace back from this point back to the light source, there's an intersection here because it's being blocked by this hammer, right? So because it's being blocked by this hammer, we say, okay, this point is a shadow. These points here are not shadows. These points here are not shadows, because when you push a ray, when you generate a ray going to the light source, nothing blocks it. So for all of these points, nothing blocks. Nothing blocks. So you generate a ray is generated from the point back to the light source, and we don't get any intersection. So there's no shadow here. However, for all of these guys here, where you see there's a shadow, um, when you see that there's a shadow, then we know that um, it's because the object went in between the point in space and the light source, right? That's my initial take on these things. um, and we could also see, based in our shaders, a telltale sign for any algorithm is its shaders. So we have our raygen, we have our miss shader, and we have our hit shader, right? And we're pretty familiar with how these things work. But we also have a shadow shader, and basically, um, what this does is exactly what I mentioned before. I will get into more details later, but basically, if a ray is generated and it hits, and it's generated towards the light source and it hits the light source with uninterrupted, then we know that it's not shadowed. However, if it is interrupted, then we know that it's a shaded, or it's a shadowed space. That's all I have to contribute for now. So, if it doesn't hit, we have shadowed as false, right? So when we run our thing, basically what we're saying is that all of these are shadowed is false because it runs back to the light source uninterrupted. But um, these guys are interrupted by the light source. So the light source is over here now, and we see it cast a shadow, right? Because it's interrupted by these objects here, right? So we're gonna let us play a game. We're just gonna put everything as shadowed, right? So everything is true. So if we make everything shadowed, if every point in our scene that goes back to our that ray that generates back to the light source is considered shadowed, what happens next? So of course, guys, we have to compile our shaders. You know the deal, guys. You know the deal. We got to compile our shaders, right? So we made a change and we're compiling the shader now. I believe I saved it. Yes. So we now have everything is shadowed, right? So regardless of whether the ray generated to the light source is intersected or not, regardless of what that situation is, we're gonna label it as shadowed, and then we have to see what happens with our application when that happens, right? So let us run our script now and see what happens. So basically, we have a scene now where nothing, everything is shadowed. So basically, the light source doesn't matter, right? All rays, all points in our scene basically is deemed as intersected. Now, our hit shader still hits, and we still get to see our we still get to see our we still get to see our object, and we still get to see like a slight brightness of the object itself. But I don't think that's not the shadows process. That's just the regular ray gen and hit process, right? Which we've seen in other applications. But as you can see, no shadow is being cast anywhere, and that makes sense because a shadow is being cast everywhere. Like there's no differentiation between unshaded and shaded part, because the whole scene is dim. And that makes sense because uh um because basically everything is labeled as a shadow, right? So if we go back to this guy and then we recompile, right, we should get back our original situationship. So that's pretty much what the big aha moment for this algorithm is. I will dive back into all of the other intricacies of um, this thing, but again, the big moment is basically the shadow algorithm, right? I mean, is this extra what they call shadow shader, right? So again, if we go back to normal, we get back our scene as we expect, right? So anyway, that's all I have to say for today. Thank you guys for watching. Check out tutorial number 1 and tutorial number 15. Not too difficult stuff, right? It's not too hard to understand. But we're making progress, guys, and we're learning in the process. So you guys have a great day. Goodbye.